From this experiment, we have to calculate determination of radius of curvature of a given convex lens by forming the Newton rings. How we have to form the Newton rings? This is a beautiful phenomena. Once you have to see, here two lenses are there. Suppose you have to take, this is the box is there. Suppose how we have to form the Newton rings, first you come to know. How many lenses are there? Two lenses are there. One lens is plain glass plate. Now you able to see how we have to observe. Is there any rotation? There is no rotation. Is there any rotation? There is no rotation. It is a plain glass, plain glass. Now you able to take this plain glass plate and then you have to take, now it is rotating, you have to see. This rotating means it is a convex surface. Inside convex surface is there. You have to take this side, it is not rotating. So that's why it is a convex surface. There is a plain glass plate. This is the plain glass plate. Which one it is? It is a plain glass plate. On the plain glass plate, you able to keep plano-convex lens. This lens we call it as a plano-convex lens. Plano-convex lens means the convex surface is attached with the plain glass plate. Now you able to see here. You able to see here. So there is a attachment is there. Inside such gap is there. In that gap, what is there? Air is there. This convex surface centered attached with the plain glass plate. Attached with what? Plain glass plate it is attached. So that's why this center there is a air is forming. In which type is where is forming? In circular shape it is air is forming. That's why you able to get the circular rings in the interferometer. So that's why you able to see that rings we call it as a Newton rings. How we have to get the Newton rings? First you have to see. First you have to take one block coated stand you have to take. So in the block coated stand you keep the plain glass plate. On the plain glass plate you have to keep a plano-convex lens. This plano-convex lens you have to incident. How you have to incident? With 45 degrees you have to incident the light. This is a sodium light. Now you able to see this lamp is a sodium vapor lamp. It is a monochromatic lamp because interference phenomena can execute only monochromatic lamps. Single wavelength lamps only can make the interference phenomena. Now you have to see here. So this light is incident on the glass plate. This glass plate you have to make it 45 degrees you have to make. So this 45 degrees if you make, then this 45 degrees light is reflect and falls on the 90 degrees on this glass plate. Now you able to see from where we have to see, from we have to see on the eye through the eyepiece from here. So this is the 90 degrees. So once you have to take this incident ray, the incident ray of the lower surface of the plain glass plate and diffracted ray, reflected ray from the bottom of the surface of the ray. These two reflected rays interfere and interference pattern can take place. In the diagram you have to see, this is a plain glass plate. Now plano-convex lens. One glass plate I am taking. This is the source. Which source it is? Sodium vapor lamp I have to take. This sodium vapor lamp I am incidenting on the glass plate. This glass plate how we have to incident? With 45 degrees we have to incident. So this reflected beam is deflected beam is incident on the bottom of the plano-convex lens and reflected back. And then one more ray is there incident with lower surface of the plain glass plate and reflected black. These two reflected rays we can see through the eyepiece. In this eyepiece there is an interference pattern can happen, that interference rings are forming. So that is the experiment, right? So which experiment we have to use to measure this rings length, rings diameter To measure the lens diameter, we have to use the traveling microscope. There in this traveling microscope, so now you have to see here the same structure is there. This is what it is. It is a glass plate. Glass plate. It is a glass plate. It is a movable glass plate. We have to move to adjust with 45 degrees. Once incident the light on this plano glass plate, plano convex lens, these reflected beams interfere, and that interference pattern we able to see through our human eye. So now we are getting that we have to adjust. This is the screw is there. So you have to move it. So this scale is moving. Now you have to take the readings. How you have to take the readings? Once you have to see the number of readings you adjust. At the reading number 20 you have to take. Suppose you have to take 1 reading, 2 reading, 3 reading, 4 reading, 5 reading, second reading. So at the 20th reading you have to take. So left side. This is the right side. This is the left side. Left side 20th reading, that MSR, main scale reading of the traveling microscope, and least count of the traveling microscope, and vernier coincidence of the traveling microscope, you have to write it. And next, this 20th reading, you have to adjust this one to this side, you have to move it. Once you have to move this side and see, keep the 20th reading. After keeping the 20th reading, you write the main scale reading. You write the main scale reading. Wherever this center line is there now, coincident in the main scale, that reading we call it as a main scale reading. And then vernier coincidence. Here once you have to see exactly this horizontal line. So horizontal line is there, here zero line is there. This zero line is coincident with this. This is the head scale reading, that is the vernier coincidence. From that vernier coincidence, you multiply with the least count, you able to get the right side reading. Now the left side reading of the 20th ring, right side reading of the 20th reading, you subtract these two readings, you will get the diameter of the, subtract, you will get the diameter of the 20th reading you able to get. After getting the diameter, you have to take the diameter square. Similarly, you have to adjust on the 18th ring, adjust on 20th, 16th ring, adjust on 14th ring, adjust on 12th ring, adjust on 10th ring, adjust on 8th ring, and so on you have to take. You take the graph, number of rings versus diameter square you have to take, diameter square. Suppose at mth ring you have to take mth ring. Now mth ring diameter square you point out, and nth ring you have to take. Nth ring diameter square you have to point out. Now you come to the find the slope. Slope is equal to dm square y2 minus y1, y2 minus y1 is divided by x2 minus x1. Dm square minus dn square is divided by m minus n. So therefore, how we have to calculate? What is our ultimate goal? Our ultimate goal is this plano convex surface. This convex surface is there. This is the plano convex surface. Which surface it is? Plano convex surface. This plano convex surface, radius of curvature we need to calculate. You have to extrapolate like this. You able to get the radius of curve. This radius of curvature we need to calculate. How we have to calculate? We know the formula. What is the formula? R is equal to dm square minus dn square is divided by 4 lambda into m minus n. But if you know that slope is equal to which one we are getting? Dm square minus dn square is divided by m minus n. This is the slope. Now R is equal to slope into this is the slope into is divided by 4 into lambda. What is the lambda? Lambda is the wavelength of the sodium lamp. You know that wavelength of the sodium lamp is equal to 5893 angstroms. This 5893 angstroms you are substituting here. So then you calculate, you will get the radius of the curvature of a plano convex lens. Clear? So this lens is correct or not? By using this parameter also, we have to calculate the radius of the curvature. That spirometer also will give the radius of the curvature, but that is the mechanical principle they are using. But here, through the optical principle, through the Newton ring experiment, we have to calculate the radius of curvature of a convex lens, not convex, plano convex lens, convex surface radius of curvature we have to calculate. In the result, you have to write the radius of curvature of a given plano convex surface is around 80 to 100 centimeters you may get in this answer. Like this we have to do. This is the Newton rings experiment. Clear? So right, like this we have to determine the radius of curvature of a convex plano convex lens convex surface radius of curvature. Otherwise, we have to calculate, if you calculate the spirometer radius of curvature by using the spirometer plano convex lens radius of curvature you have to calculate, then you find the unknown value of the wavelength of the light also you have to calculate. How we have to calculate? Lambda is equal to slope is divided by 4 into r. If you know the r, automatically you able to calculate the wavelength of the light of a sodium lamp also in this experiment. But we are taking the fundamental formula of the wavelength of the sodium vapor lamp. Now we are calculating which one? Radius of the curvature, because we don't have the spirometer in this laboratory. Clear? So please share and subscribe and like our YouTube channel. Like these videos, we will upload you for your edification of physics knowledge in the laboratory purpose. Clear? Thank you so much.